Okay, problem number one. It says given rhombus ABCD, and part A is asking us if the rhombus is going to be a rectangle, what would have to be true about the diagonal? So if you go back to chapter 6, there are properties of rhombus, properties of rectangles, properties of squares, right, and all the other shapes that we talked about that were quadrilaterals and parallelograms. So if we say that this is approximately our rhombus, if we want the diagonals, if we want it to be a rectangle, one of the properties of a rectangle and its diagonals is that it would have to be equal diagonals. So when you draw the two diagonals, you would have to say that they are the same length, and that would be the answer for problem number one. So that's just knowing your properties from chapter 6, okay, in the book. Okay, and then letter B is related to that. It says if the slope of segment BC. So let's draw this, and it'll say this is about AB. CD, right? So when they name a rhombus or any other shape, we usually go clockwise around the shape with the letters that they gave us, right? So I did A, B, C, D, okay? And they said BC has a slope of 1/4, okay? What would the slope of AB be, okay? So we're comparing two line segments that intersect each other at point B, and in order for this to be a square, there would have to be a right angle here at B, right? Because squares have right angles in all the corners. And so what we said about slopes, in order to make a perpendicular line, the 1/4 would have to go with AB being the opposite reciprocal, which is -4/1. So we'd have to say that AB would have to have a slope of -4, right? Perpendicular lines always have opposite reciprocal slopes, okay? So problem number 2, it says two sides of a triangle have lengths 6 and 8. Which inequalities represent the possible lengths of the third side? So they're claiming that we have a low point and a high point for the third side. So we're going to actually think about one of the rules we said, which is basically in a triangle, right? So here's a kind of a side example, not using these numbers. If I had, like, for example, 2, 3, and 7, I would claim that this cannot be a triangle because when you add up the two small sides, in this case the 2 and the 3, 2 plus 3 is not bigger than 7. And in order for it to be a triangle, it would have to be bigger than 7. So we would say that this triangle does not exist. Right? So what we're looking at with ours is, well, if these are the small sides, if I'm looking at my triangle and saying 6 and 8 are my small side, 6 and 18 are my small sides, and I don't know the third one, well, if I add together 6 and 18, I get 24. So 6 plus 18 has to be bigger than the third side x, which means x has to be less than 24, right? So that allows us to pretty much choose letter C. But let's talk about why the other side is 12, right? The other possibility besides x being the biggest side is maybe 18 is the big side and x is maybe the medium-sized one or the small one, right? So if we said 6 plus the medium-sized one, x, well, that has to be bigger than the largest side, which maybe it's 18, right? So if I solve this one, you can see that I'm going to get that x has got to be greater than 12, right? And so that's the other side. So a nice simple way to thinking about it is in this one, the 6 and the 18 got added together, and in this one, we did 18 minus 6, right? So if you take the two sides that they give you, you add them, you get one side, and you subtract them, you get the other side. So we'll say in this case, choice C, because it can be anywhere between 12 and 24. Okay, problem number 3, all right, so in congruent statements like this, triangle STU is congruent to triangle KLM. Any parts that are in the same part of the name, for example, ST is the first two letters and KL is the first two letters, that those would be the equal side. So right away we can see that this first one doesn't work out. This one is not true. Okay? Oh, I'm sorry. Let me reread that. It says, which can you not conclude, right? So let's just check the other ones, because this one, it is still A, right? I read it correctly. So it says TU and LM, those are both the second and third letters, so that one's good, right? So we're going to say that we can conclude that. Angle T and angle L are both the middle letters, so we can conclude that. And S and K are both the first letters, so we can conclude that. So ST and KM are not congruent in this case because they do not occupy the same spaces in their names, okay? Problem number 4. So this one is saying each unit on the map represent 5 miles. We're going to use that at the end. And they want to know the distance from oceanfront to seaside. So if you have a coordinates, either whether it's given to you on a coordinate plane or just listed as point, you should use the distance formula. And this is something that you do need to know. This will not be provided to you. So here it is if you don't have it. Okay, so we subtract the x values from each point, and we subtract the y values from each point, square them, add them together. So basically do the Pythagorean theorem. And they care about oceanfront to seaside. So if I pull those points out, I'm going to say oceanfront looks like it's at 3, comma, -2. Okay, and it looks like seaside is at -2, 4. Right, so I'm going to now plug these in, and it's going to say the square root of, well, 3 minus -2, okay, and the order that you plug these in does not matter, okay, and that just as long as you're consistent, I call this one x2, which means I have to call this one y2, so I'll say now -2 minus 4 squared, okay, and so if this now looks like 5 squared, right, which is 25, and this looks like -6 squared, which is 36. Okay, so just be careful again with things like parentheses. All right, so that looks like 61. So we're going to take the square root of 61. If you take the square root of 61, you get something a little bit smaller than 8. So we're going to say about 7.8 or 7.9. Okay, so the square root of 81 is about 7.8. If you take a look, we do have an option here for 8 miles, right? So that's what a lot of people would go for, but this is where we have to be careful. Each unit on the map represents 5 miles. So if we take a number about 8, a little bit smaller than 8, and we multiply it by 5 miles, we're actually going to find out that it is 40 miles long. So be careful that you're reading things like that each unit represents 5 miles, okay, because the other choice is there. Problem number 5. What is the measure of one interior angle of a regular 25 gun? So again, formula that will not be provided to you, 180 times n minus 2, where n represents the number of sides of the shape. Okay, so let's do this first. This will get us the sum of all of the angles. We're asked about one of them, so let's find the sum of all the angles. We're going to do 180 times 25 minus 2, aka 180 times 23. So let me grab my calculator and do 180 times 23 sides, and that's 4140. Right, so I'm going to say 4140 represents the total number of degrees in this 25-sided shape. If they want to know about one of them, I then need to divide that by 25. Right, and so if I do 4140 divided by 25, I get 165.6, which is each of the 25 angles is 165.6 degrees. Okay. Problem number 6, it says find the length of xpy. So this is the length of an arc formula, is one of them that will be provided to you on the formula sheet. So that formula used the letter m, which represents the measure of the arc, over 360 times pi d, or it might say 2 pi r, which means the same thing, right? 2 radius and 1 diameter are the same. So I'm going to look at this, and you need, again, be very careful. This says xpy. That means start at x, travel in the direction of p, and end at y, which means they actually want this arc here, the major arc, right, not the minor arc. We're going that way around, okay? So I'm going to say, how many degrees is that? Well, if the short way is 90, the long way is 270 out of 360, okay? And my diameter, if my radius is 4, my diameter would be 8, okay? So this actually, I'm sorry, 8 pi, not 8d, okay? So 8 pi, okay? And so this simplifies, again, see, leave your answer in terms of pi, which means we're not going to multiply by pi. So if I simplify this is 3 over 4. Okay? There are 90s in both of these, okay? So I'm going to say divide that out times 8 pi, okay? And if you're trying to simplify this, we can say there's a divide by 4 on the bottom, and that leaves 1 behind. Divide by 4 right here with the 8, and that leaves 2 behind. And so this would turn into 3 times 2, or 6 pi. All right, so 6 pi meters would be the length of xpy. Problem number 7. So this is similarity, right? So this is, they're telling us that PQ and BC are parallel to each other. And so what happens when we have parallel lines inside of a triangle is that the segments that are created, the 4 and the 20 and the x and the 45, create a proportion. So here's what we're going to write. We're going to say 4 over 20, which that's the 2 lines on the left, equals x over 45, and that's the 2 line segments that were created on the right. So I'm going to save myself a little bit of work. 4 over 20 is really just 1/5, right? Instead of spreading around a gigantic 20. Okay, this will be a little bit easier. So this really says 5x, and when I go this way, I get 45, and so it looks like x has to be 9, right? So I would say similarity, and the way I remember this is if I just kind of draw the line out a little bit further, it actually sets up the fraction for you. X over 45 on the left, 4 over 20 on the right, and that's what we wrote in this space here. Okay, so simple solve, but you have to understand that parallel lines give you similarity. Okay. Problem number 8. The area of a square garden is 98 meters squared, and they're saying based on that, they want to know how long is the diagonal. So let's draw ourselves a square. Right? Anytime they don't give you a picture, you should draw yourself a picture of what's happening. So here's my square, and they're claiming the inside of this is 98, the area of the inside. So we have to think about what is the area of a square formula. Well, that would be length times width or side times side. So I'm going to actually say in this case, side squared is equal to the area. And that's because the sides are the same. If I call this one S, this one's also S because it's a square. Right? So I'm going to say in this case, for our problem, they told us 98. Okay? And if you square root both sides here, you can say that S equals the square root of 98. And in this case, the square root of 98 is about 9.9. Okay? So I would say 9.9 represents one of these sides. Okay? Now we have to use that 9.9 to figure out the length of the diagonal. How long is the diagonal? So I'm going to erase my 98 and draw on a diagonal so I can see what happens when I draw that diagonal in. So when I draw a diagonal in here, okay, it looks like I just made two right triangles, because remember, squares have right angles everywhere. And these 90-degree angles got split into 45s, okay, everywhere. And so I made two 45, 90s. And if I know this is 9.9, well, I can say that this would be 9.9 times the square root of 2. So it's possible that your answer might look like that. 9.9 times the square root of 2. Sorry, that's not S, that's the diagonal. Okay, so we'll call that D for diagonal. Right, so it's possible that it might look like that. The other possibility is maybe they won't square root 98. So I'm going to come over here and say, well, the square root of 98 is really the square root of 49 times the square root of 2, which is 7 root 2. So instead of taking the square root, if they say in radical form, maybe they'll present answers on a multiple choice in radical form. If this is worth 7 root 2, right, my side, I would have to take that then and also multiply it by the square root of 2, right? And this looks like 7 times 2, right? Square root of 2 times itself is 2, so it would be 7 times 2, which is 14, right? So 14 is the most accurate answer, right? Which came a little bit off the bottom of the screen, right? So 14 is the most accurate answer, but it depends on how they ask you for your answer, whether it be radical form or simplest radical, or rounded to the nearest. Okay, problem number 9. It says find the area of the shaded region. So here's what I see when I see the shaded region. I see this big sector here that goes all the way around, okay? And so let's find the area of that before we touch this triangle. The other part's going to be this triangle, which we'll find separately. So again, on your formula sheet, it will say for the area of a sector, any part of a circle, okay, the inside, we'd say arc over 360 times pi r squared. And so we're going to plug in what we know. If this little piece is 60, this is the rest of it, which is 300. Right? So 300 over 360 times pi, and there's my radius of 12, so 12 squared. Oops. Okay. So when I simplify this again, 300 over 360, it looks like I can divide the top and the bottom by 6, and I'd end up with 60, and I'd end up with 5/6 times 144 pi, and I believe 144 will divide evenly with 6. Okay. It does. Oh, I did it wrong way. 144 divided by 6 is 24. So if I cancel this, I would say this divides with 6 and becomes a 1. This divides with 6 and becomes 24. And then I just have to do 24 times 5, okay, which is 120. So this little section of my of my circle is 120 pi meters squared. Right? So that's the first part of it. I got to do the same thing with the second part. So I'm going to get rid of all this work, because now we have to do the triangle, right? So this little triangle needs to be added to this 120 pi. So let me grab a triangle. So again, I highly recommend drawing yourself a picture, right? And so I'm going to say this is 60, okay? And they told us that one of the sides was 12, and that's all we know, okay? So we have to figure out what the area of this shape is, and that's all we know. So the other thing that we know is that the other unmarked side around 60 is also a radius in the circle, which means it's also 12. And this makes this an isosceles triangle. Across from the 12s have to be equal, and so if I take the remaining 120 and I cut it into equal pieces, I also get 60 and 60. So now I can actually conclude that this is also an equilateral triangle, because if all the angles are equal, all of the sides have to be equal as well. So I'm going to take that top 60 and I'm going to actually cut it, Because my formula for the area of a triangle is 1/2 base height. Right? And so my base here is 12, which I'm going to split up into 6s. Okay? And the 30 up here, I'm sorry, the 60 up here becomes 2 30s when I draw in that altitude, 30, 60, 90. So if this is a 30, 60, 90 special right triangle, the 60 across from the 60 is the long leg, and that is the short leg times the square root of 3. So I know my height is going to be 6 square root of 3. So let's plug this in. Now it says 1/2, the whole base across, remember, is 12, and the height is 6 root 3. Right? So it asks us to leave our answer in terms of pi in simplest radical form. So I'm going to say this becomes 36 square root of 3. Okay? So this is the area of the triangle. So if I want to write an expression that represents the area of all of this shaded space, I'm going to say it's the 120 pi plus the 36 square root of 3 that we got from the triangle. So this would be your final answer, okay? And it's in meters squared because we're talking about an area, right? So finding the area of each of those pieces, add them together, and you have your answer. Problem number 10. Okay, so you have to be careful with problem number 10. So this looks like a square or a rectangle or something like that, but it's not, and that's because the bottom is a little bit small, a little bit bigger than the top is, right? So this is actually a trapezoid, and again, you'll be given a trapezoid formula. It's 1/2 the height times the sum of the bases. And so my bases are the 9 and the 8, so I do know those, so I'm going to plug those in, 9 plus 8. Okay. I don't, however, I was not given the height, right? That's the distance from the bottom to the top. And so here's what we're going to use the circle. We're going to say if it's 4 over to the edge here, it's also 4 up, and it's also 4 down, which means the distance from the bottom to the top is actually 8, and that's what I'm going to use for my height. So I'm going to say the area of the trapezoid is 1/2 of 8, which is 4, right? And then 4 times 9 plus 8 is 17, so 4 times 17 is 68. Right? So the area of the entire space is 68 square units. Right? Now we have to take away the area of the circle because that is not shaded. So this is just, if I come off below here, I'm going to say the area of a circle is pi times r, which is 4 squared. So that's 16 pi. So I'm going to, again, take my entire length, 68, and I'm going to subtract off the circle inside that was not shaded, and I would say this is the area of the shaded region, 68 minus 16 pi. Okay, we have a few more problems to go. Problem number 11. Okay, so this says angle 1 and angle 2 are linear pairs, and if they give you an expressions for them, they want to know the measure of each of the angles. And so linear pairs, again, there's vocabulary for you. This means that they create a line, and we know that lines always add up to 180. So I'm just going to say that x minus 25 plus x plus 69 should equal 180. So x and x gives me 2x, and when I do 69 minus 25, that looks like 44. Okay, so I'm going to say plus 44 equals 180. Okay, so now I need to do 180 minus 44. 2x is equal to, that looks like 136, right? And that makes x, in this case, cutting this in half, I would get 68. Okay, so 68 is x. But again, be careful, that's not what they asked for. They asked for the measure of the angle. So I'm going to say the measure of angle 2, I need to place a 68 right there. So I would say the measure of angle 2 is equal to 68 plus 69, which is 137 degrees. And the measure of angle 1 would have to be the rest of the 180, or you could just go plug it in right there, whichever one you like. And that looks like it would be 43, right? 43 degrees. So here's the measure of angle 1 and the measure of angle 2, which is the answer to their question. All right, problem number 12. I see a 45, 45, 90 special right triangle. So to remind you about the rules for those, we said in 45, 45, 90s, the legs are equal. So this one would also be 3 root 2. Okay, sorry, 3 root 2. Let's try that again. 3 root 2. There we go. All right, and then the hypotenuse would be those legs, pick one, right? So hypotenuse is equal to leg times the square root of 2. So I need to take a 3 square root of 2 and multiply it by the square root of 2, and that will give me the length of the hypotenuse, which is what they asked for in this problem. So again, be careful. Square root of 2 times the square root of 2 is just 2. So I'm going to say my final answer here is 3 times 2, which is 6. Right? So my hypotenuse for this problem is 6 units long. All right, problem number 13. They want to know the exact area of the shaded region. Exact means leave your answer in terms of pi and in simplest radical form. And so they were nice in this problem. If I'm finding the area of this shaded space, I'm going to find the area of the AOB sector that includes the triangle and that shaded space, and then I'm just going to subtract off the triangle. Well, the nice thing with this problem is that they actually did that for us already. 56.25 pi is the area of this entire space. So if I remove from this 56.25 pi the area of the triangle, that's going to give me the shaded region, this little shaded space, which we call a segment. Right? So the area of this triangle, I'm just going to kind of come off to the here. Remember, triangles are 1/2 base height. Right? And so the question is, what are my base and my height for the triangle? Well, it looks like the base is 15. So I'm going to put a 15 there. And so the question is, well, what's the height? Well, in the circle, the OA is a radius, so it means it's also 15. Okay, so this looks like 1/2 of 15 times 15. 15 times 15 is 225. Okay, and you're going to multiply that by a half, and you get 112.5. So the area of just the triangle is 112.5. So the answer to their question is, if I take 56.25 pi, which is the area of this big sector, and I subtract off 112.5, that would, and in this case inches squared for area, right? That would be the area of the little shaded region. Okay, problem number 14. They want to know the value of x. So this is a sine, cosine, tangent problem. So we're going to set this up and say opposite from x is the 14, and then 16 is my hypotenuse. Opposite and hypotenuse is sine. So I'm going to say the sine of the angle is equal to opposite over hypotenuse. Right? So to get x alone, we use inverse sine. So if I inverse sine this expression, that's the little sign with the -1. These will cancel each other out, and I'll just get x. So then I also need to take this expression and inverse sine. And so my answer is the inverse sine of 14 over 16, which again, you can go to your calculator, make sure it's in degrees mode, right, and do 14 over 16, okay, and then take the inverse sine of that. So I'm trying to find that on my calculator. So I'm going to say inverse sine. There it is, inverse sine. So you should get 61 degrees rounded to the nearest degree. X is equal to 61 degrees. Okay, so again, use that inverse sine button, which is usually located right above the sine button on the calculator. Okay, problem number 15 is also asking to use trig, but in this case, we know the angle and we're trying to find the side. So I'm going to say, in this case, again, opposite is 8, and adjacent is x. So this looks like a tangent problem. So tangent of 40 equals 8 over x. Right, so remember, the quick way that we did these problems is we said we had a rule that you're allowed to, in a proportion, switch something on a diagonal. So I can move the x over here and move the tan 40 back, and it'll look like x equals 8 over the tangent of 40. So again, this is after this, just make sure your calculator is in degrees mode, and then you're going to go to your calculator and type in 8 divided by the tangent of 40, which looks like 9.5, right? And so here's one other thing to keep in mind. Okay, make sure that your answer looks reasonable. Don't just write down whatever comes out of the calculator, because if we got something like 0.035 or something strange like that, maybe your calculator's in the wrong mode. Well, if I looked at the other side and was like, wait, well, one of the sides is 8 and the other side is a number smaller than 1, that doesn't really make a whole lot of sense. 8 and 9.5 seem like they should be together. Okay, so here's the last problem that we're going to do on this review. Let me move it up a little bit. Okay, and so they want us to know. They want to know if we reflect this over the y-axis, what are the coordinates of A, B, C, and C prime? Right. So these are symbols of prime. Right. So reflecting over the y-axis, reflections are the same distance but on the opposite side of the line. So I'm going to take this y-axis and I'm going to move this point. Well, it's 2 units to get to the axis, so that means that A prime exists 2 units on the other side. So A prime is the point -2, 2. And then I'm going to just do that with all of them. If I go 1, 2, 3, 4 to the right, that means I'm going to go 1, 2, 3, 4 to the left. There's B. Okay. And so that looks like the point -1, -2, -3, -4, up to 1, 2, 3, 4, 5, 6. So B prime is -4, +6. And then C, I got to go way over here to -9, 1. So I'd say C prime, -9, 1. Right, and that would be the C prime. So you don't even have to connect these together if you don't want to. Let's just make sure that it looks like the same shape, and it does. So that is a good reflection, and those are the points that they asked for.